Alright.
I'm nervous. No one wants to hear this.
Oh, gotta get in the frame.
Alright, so when you go, I'll step behind you.
Okay.
And why don't we?
Did I rock?
You
Did I
can't
rock
get
it?
into work. You weren't rocking as much.
As much, or so it's rocking?
I think you rocked a little bit, but I don't think it was. The first time you were just seriously like on the boat.
I saw you walk off screen for a minute, and then you like.
So why doesn't this work with the...
Do I do anything to you?
Don't worry about it. Okay. If you guys are fine with it.
I'm fine without looking at it too much. Ready?
Damn.
3,
Fuck this shit. I hate
2,
this.
1.
Is it recording?
Go.
Yep.
We're on the green, and this is the hybrid electric golf cart project.
I'm Jason Brown. I'm responsible for wiring, electronics, competitor research, and energy analysis.
I'm Chris LaBianco. I'm responsible for mechanical repairs, component installation, and material analysis.
I'm Stephen Kibbins. I'll be performing structural analysis as well as coordinating the budget and purchasing parts.
And I'm Anthony Sinfei, and I'm in charge of the CAD modeling, controller programming, and any media.
Our project is to create a conversion kit that will transform any existing vehicle into a gas-electric hybrid. That means you can buy our kit and transform the car that you already own into a fuel-saving hybrid. For budget reasons, we chose a golf cart as our test platform, but the kit is intended for full-size vehicles. There are many reasons why there needs to be a hybrid kit, the first being high gas prices. Seen in this chart is gas prices in the United States for the last 6 years. You can see that the prices are very volatile and that there is an upward trend. Right now prices are low, but it is likely the prices will increase in the future. Therefore, a kit is good because it will soften the impact that higher gas prices will cause. Next is global warming. This slide shows the CO2 emissions for the end-use sector. You can see transportation leading with 2 billion metric tons of CO2. It leads industrial, residential, and commercial end-use sectors. We hope by producing a hybrid kit that the CO2 emissions caused by cars will lower the transportation sector. Finally, hybrid cars are expensive. Here you can see 10 hybrid cars with their comparable base model. The blue bars represent the base model price, while the red bars represent the hybrid price. Hybrid cars are on average 35% more than the base model cars.
And as in any design project, the engineers have to work around several limitations. Our first big limitation is our available budget. We're hoping to be working around $3,500, hopefully provided by Progress Energy. And because we're using a golf cart as a rolling platform, the scale, the results of the model, or the results may not scale proportionately to a full-size vehicle. One big aspect that we're trying to aim for is making this kit as easy to install as possible. We are aiming to have an experienced mechanic spend a weekend, about 18 hours, to install this kit with the use of standard mechanic tools. Because the golf carts are already so small, we have to take into account the space limitations. We aim to design this kit to be as small as possible and to allow for more storage space in the end. And working around these limitations, we hope to build a hybrid electric conversion kit that will convert an existing car to a gas-electric hybrid. We aim to increase vehicle fuel efficiency by a minimum of 10%, and we want to design the user interface from last year's project. Unlike last year's project, we aim to have this car operated by one person, and we do not want the owner of the car to receive any extra training to operate their car.
The following is the functional requirements of the hybrid conversion kit. From the performance aspect, we would like to provide the customer the ability to improve his non-hybrid vehicle, the ability to improve it 10% more efficiently. Safety is our #1 concern. Customers should feel comfortable behind the wheel. This means that the driving characteristics of the vehicle should not change, such as stopping, accelerating, and handling. This kit should enable the vehicle to travel longer distances with less fuel. Our kit will have the greatest impact on city driving. This is where vehicles are least efficient with several stops and accelerating. We would like to supply this kit to the public for a reasonable cost, as opposed to purchasing a new hybrid vehicle. We also want to allow the customer to buy replacement parts off the shelf for affordable prices. This kit should be able to be installed within a weekend with standard mechanic tools. We want to minimize the weight of the kit to under 25% of the original vehicle's weight. And we want to maintain as much of the storage space as possible. This kit should be able to be removed from the vehicle without changing the performance of its original. This vehicle should remain, the physical appearance of the vehicle should remain the same since all the components will be installed under the body. We've been given an 8-month deadline to complete this project, and with the budget provided by Progress Energy, we hope to build a small-scale prototype using a golf cart. The kit should not affect the ride comfort. The engine should engage seamlessly, and the integrated controller should make it easily operable. This is the Gantt chart. It shows project milestones. Each different color represents a different teammate, as well as blue represents the team as a whole. The black bars filled in means that they have been completed. The first thing we had to do was obtain a golf cart, which we have done. Another major milestone is rebuilding the gas engine that came with the golf cart. Currently does not start. In November, we will begin CADing our design, which Anthony has been designated. And over winter break, we plan on purchasing parts.
Given the requirements that were provided by our faculty advisor, we created a web poll to help evaluate the importance of each customer requirement. The web poll results helped us develop the relative importance of each customer attribute of the kit for our house of quality. This is our house of quality. On the left side is our customer attributes, and the top 5 attributes that we found were the reliability, fuel consumption improvement, onboard power generation, cost, and serviceability. The top of the house of quality shows our engineering characteristics that were selected to help us achieve each of our customer requirements. The roof of the house of quality shows the relationship between each engineering characteristic, and the onboard power generation affected the largest number of other engineering characteristics. It affects everything from the weight to cost, number of components, efficiency, and yeah. We had 3 competitors that we found for our project. Last year's hybrid electric golf cart team did fairly well. There's also 2 companies that make hybrid conversion kits, Reinvolt Technologies and EV Power Systems. The Reinvolt Technologies kit costs approximately $18,000 and requires 2 to 6 months to install. We'd like to improve that by a substantial margin. We selected targets for each of our engineering characteristics. We wanted to not have to service the vehicle for 125 hours after installation, which is the same as the golf cart recommended maintenance interval. We also wanted to fit all of the costs of the components in a budget of $1,500, and we want the kit to be installed and removed in 18 hours.
And for more information, feel free to check out our blog. We'll be updating it regularly with pictures and videos and other media for you guys to check out. This concludes our presentation. We'll take any questions you guys may have.
9 minutes.
Nice.
Okay.